Okay, so this is the +3 Vitos crank, +3mm Vitos crank. This is a second-hand example. Here in South Africa, they're not easy to come by. So when they're available and you find one, you need to grab it immediately. What you see here versus a stock Yamaha Blaster crank or crank stuffers. These are plastic inserts which have been put into the crank. There you can see it sticking through, and that side as well. That's part of the stuffer. They're inserted into the crank lobes for the purposes of decreasing crankcase volume. We know that crankcase ratio in terms of pumping from the crankcase into the master, into the cylinder, in terms of its displacement, is very important in terms of efficiency. If we don't have these in here, we increase crankcase volume, which lends the bike to a more low-mid scenario. Whereas with the stuffers, you get high, low, mid, mid and high based RPM efficiencies with the engine. So back to why this crank is important in this video series that I'm doing on the potential achievement of 40 horsepower in a Yamaha Blaster. Where this fits in terms of importance is this is video part 3. In part 2 we discussed a quick unboxing of a connecting rod, which from its center there to its center here was 110 millimeters on the stock Blaster, and the unboxing was of a 115 millimeter rod. That is 5 millimeters longer in length. We will go into some theories and mathematics about longer rods and how these work. We'll do rod ratio calculations, and we'll try and show you there is a benefit in a certain engine design when using a longer rod, which is what the basis of this motor build is derived from. So we're going to split this crank, and we're going to put the 115 millimeter conrod on with all the brand new paraphernalia. And this is a +3 Vitos crank. So what this means is, I'm going to put this to the side. Okay, we can't. So I'm just going to put the camera to the side. How's that? So what that means, guys, is that on a stock Yamaha Blaster, we have a 57 millimeter length of crank throw. Okay, that is our stroke, 57 millimeters. Now, when we say this is a +3 stroker crank, means we have increased the stroke from that 57 millimeters by 3 extra millimeters. Doesn't mean that we've increased it by 3 millimeters in one direction and 3 millimeters in the other. It means we've done 1.5 millimeters of increase. What that means is this crank pin used to be 1.5 millimeters further down. Its center point was further down by 1.5 millimeters, making it a 57 millimeter stroke. But we moved this one as a +3 on the Vitos crank up by 1.5 millimeters. What that means is, at top dead center in this position, when your piston is all the way at the top and your conrod is all the way at the top, then you have achieved an extra 1.5 millimeters of stroke. And when your crank is at bottom dead center, okay, when the conrod and the piston are at their most bottom point, that means that the most bottom point is moved down further by 1.5 millimeters as well. So the two areas 180 degrees opposed in terms of crank rotation are 1.5 millimeters longer. So the 1.5 increase and the 1.5 at the top dead center, and the 1.5 increase at bottom dead center, those two add up to 3 millimeters. That's why this is called a +3 crank. A lot of you guys already know that, but I'm only telling you so that the other people in the video who may not have known that understand it. So what does this mean? This means that, hopefully I can draw this for you, we'll have a piston with a rod connected to it. I'm trying to draw this with my phone being held in the left hand and drawing with the right hand. That's the crank. Sorry, that's a very, very bad crank. I lie so much through my teeth. The crank actually looks like this. Okay, and the crank pin is at the top. We'll call that the other crank web on the other side. How about that? Get away with nonsense. So that's the center of the crank, and our pin is now 1.5 millimeters high up. So in the barrel, when this piston at top dead center used to hit deck height of 0, which means it was absolutely level with the top of the barrel, we now have a scenario, because we've got 1.5 millimeters of extra throw, we now have a scenario where the piston sticks out above the deck. Not exactly, and we'll explain in a later video, but for your understanding right now, an additional 1.5 millimeters. So your piston will now hit your head. All right. So what they do, Vitos, is they supply the Conrod kit, the plus 3, sorry, not the Conrod kit, the crank kit, the plus 3 Vitos crank kit. They'll supply it with a spacer, and that spacer, including the gaskets on either side, will raise the barrel enough to bring the piston back to deck height. Because it's sticking out 1.5, you raise it by 1.5, it will be back to deck height, 0. So it won't hit the head. What that will also do is, remember, your port timing, because your piston's sticking out that much further, used to be here, or is there at this point because of the piston stick out, and it actually needs to be there to compensate for that. So when we put the spacer plate with the gaskets in and raise the barrel, we then bring the port heights all back into the correct geometry. So in video part 2, we unboxed a 115 millimeter Conrod. This is 110, which is what the Vitos crank comes with. So now we have to deal with the second problem, and in future videos we'll get into the math and the theory of it as explained. We now not only have this additional stroker crank 1.5 millimeters of stick out of the piston, we will have an additional 5 millimeters of stick out, because we don't have 110 more rod anymore. We've got 115 more rod. So we have 1.5 plus 5 millimeters of extra stick out of the piston. So theoretically, to get the port timings back into place and to get the top of that piston in line with 0 deck height and not hit the head, we would have to make a spacer plate which includes the 2 gaskets and their thicknesses on either side, thick enough to bring this down. Theoretically, not exactly, because of pi and all of that nonsense. 5 plus 1.5 is 6.5 millimeters of additional gasket and spacer plate thickness will be needed to raise that barrel to get that piston the same as 0 degree deck height. Thank you for watching. We'll explain more in the next video.